Okay, so on Thursday we discussed dual units, and I want to take a little bit more time to work with those dual units. I'm going to start out with our standard units. What we're looking at, of course, is standard rates. Rates, remember, are a combination of dual units. A rate is two numbers that have different labels or different units, so that when we create that comparison, we have to have the units in there to complete the comparison. So we might have something like 9 cubic feet per minute converted into gallons per hour. Well, I want to make this conversion here. I am going to write this. First thing I have to do is write this as a full rate rather than the abbreviated rate. What we have right here, this is the rate is abbreviated so that the units are only, labels are only in the unit there. We've lost the whole fractional appearance of the rate. So to write it out as a full rate, it's 9 cubic feet on top, and the per minute is actually per 1 minute on bottom. And now we have to change both of those units, as we saw on Thursday. So I'm going to start out with changing the top unit, the numerator. That's cubic feet, and we need to change it to gallons. So I'm going to get rid of the cubic feet by putting it on bottom, and I'm going to gallons. And we look up our equivalency, we find that 1 cubic foot is 7.5 gallons. So now we put the cubic feet on bottom so that they would cross cancel out with the one that was already there. So the cubic feet are gone. Right now our units are gallons per minute. We want gallons per hour. So we need to change those minutes. So to get rid of them, since they're on bottom, I'm going to put them on top. And we're going to convert to hours. 1 hour is 60 minutes. So again, the minutes will cross cancel out, and we now have gallons per hour, which is what we want. So on top, we have 9 times 7.5 times 60, 4,500, or 4,050. That is gallons on top. On bottom, 1 times 1 times 1 hour is just 1 hour. So that is simply 4,050 gallons per hour. Slightly different calculation. Would be 25 cubic inches per second. And let's convert that into gallons per hour. I'm going to give you about a minute in your notes to do that conversion on your own, and then we will go over it and see how you did. Hold up so you can see. Give that one a try and we'll go over it. So we'll start with the 25 cubic inches per 1 second. We have to write it as that fraction to work with it. Now we need to change the cubic inches into gallons. So cubic inches will go on bottom. gallons on top. If we look up the equivalency there between cubic inches and gallons, we get that 1 gallon is actually about 231 cubic inches. Cubic inches have canceled out. We are now gallons per second. We want gallons per hour, so we have to get rid of the seconds. Seconds are on bottom. We're going to put seconds on top, cancel them out. We'll go to minutes first. 1 minute is 60 seconds. Seconds cancel out. And then we'll get rid of the minutes. Go to hours. 1 hour is 60 minutes. Minutes cancel out. We now have hours. So on top, we have 25 times 1 gallon times 60 times 60. 9,000 or 90,000? I believe it's 90,000. It is 90,000 gallons. Over on bottom, we've got 1 times 230 times 1 times 1 hour, so that's 231 hours. Take the 90,000 divided by 231, is 389.61. Gallons per hour. Just under 400 gallons per hour. Well, we also have things like 65 pounds per square foot. And I might want to convert that into ounces per square inch. So our conversions are going to be the same. We start out as 65 pounds over 1 square foot. We have to get rid of pounds. Pounds need to become ounces. So we're going to put pounds on bottom, ounces on top. And our relationship there is 1 pound equals 16 ounces. So the pounds cancel out. We now have ounces per square foot. It's closer to 1 ounces per square inch. So I have to get rid of the square feet. Square feet's on bottom here, so we're going to put it on top. 1 square foot is 144 square inches. So the square feet cancel out. We now multiply 65 times 16 times 1 is that 200, I believe. Let's do that by a bit. 1,045, okay? 1,040. 1,040 ounces over 1 times 1 times 144 square inches is 144 square inches. And we do have to divide. 1,040 divided by 144. It's 7.22 ounces per inch. Well, another conversion that we can run to similar to this is we might be told that we're looking at 1.5 tons per acre. I might want to know, what is that in pounds per square foot? So again, we start out as 1.5 tons over 1 acre. We have to get rid of the tons. The tons are going to have to become pounds. Tons on top here, pounds on top there. We're going to put tons on bottom and pounds on top. We know that 1 ton is 2,000 pounds. That's our relationship. So the tons have canceled out. We now have pounds per acre. Well, for the acres, let's put acres on top, and we're going to go to square feet because we want to have acres on the numerator or the denominator. We want square feet in the denominator. We know that 1 acre is 43,560 square feet. Acres cancel out. We are now in pounds per square foot. So on top, we have 1.5 times 2,000 pounds, 3,000 pounds. On bottom, 1 times 1 times 43,560 square feet. Divide that out. 3,000 divided by 43,560. We have 0.069 pounds per square foot. So less than 1/10 of a pound per square foot is what that application would be. We might have a material. Typical wood actually goes between 28 and 75 pounds per cubic foot. Let's look at a wooden material that we have 45 pounds foot. I just want to change it to pounds per yard. I'm only changing one of the units here. 45 pounds, 1 cubic foot. And I want to change the cubic foot, cubic yards. So I put cubic feet on top, cubic yards on bottom, so that the cubic feet will cancel out. 1 cubic yard. Now we got to remember here, a foot is 3, or a yard is 3 feet. A cubic yard is 3 by 3 by 3. 3 times 3 times 3 is 27. 27 cubic feet. So we've got 45 times 27, giving us 1,250 pounds. On bottom, 1 times 1 cubic yard is just a cubic yard. So that's 1,215 pounds per cubic yard. In your notes, I want you to try one here. We're going to go 4 pounds per cubic foot. I want you to get that in ounces per cubic inch. I'll give you a minute or so, and then we'll go over that one. So, start out as 4 pounds over 1 cubic foot. Here's the pounds. So we're going to put pounds on bottom, ounces on top. 1 pound is 16 ounces. Pounds have canceled out. We're going to get rid of cubic feet. On top here. 1 cubic foot is 1,728 cubic inches. Remember, it's cubic. So it's 12 by 12 by 12. 12 times 12 times 12 is 1,728. Gone. On top, we've got 64 times 16. That's believe that is 1,024 ounces. On bottom, 1 times 1728 is 1,728 cubic inches. Divide that out, we get 0.593 ounces. A little bit more than half an ounce per cubic inch. We have other rates that we might be looking at. We might have a time-based rate. Similar to our gallons per hour, we might have 8 cubic inches per second, and we need to convert that into cubic feet per hour. 8 cubic inches over 1 second. And we have to convert the cubic inches into cubic feet. 1 cubic foot, again, is 1,728 cubic inches. That cross cancels the cubic inches. And we have to get rid of the seconds. Now, normally I do seconds to minutes and then minutes to hours, but we've already done that once today. So I'm just going to know 60 times 60 is 3,600. 1 hour is 3,600 seconds. Save us a little bit of time. So on top, we've got 8 times 1 cubic foot times 3,600. 28,800. On bottom, 1 times 1728 times 1 hour is 1,728 hours. $16.67 per hour. It's actually a pretty rapid rate. We might have some mixing, whether you're looking at fuel mixtures, adding oil to fuel for a 2-cycle motor, or other additives. Let's say we have something that is listed as B 0.3 ounces per tablespoon. We want to know what is that going to be as an additive in pounds per gallon. 0.3 ounces over 1 tablespoon. I get rid of the ounces and go to pounds. So I'm putting ounces on bottom, pounds on top. 1 pound is 16 ounces. So the ounces cancel out. We're in pounds per tablespoon. We get rid of the tablespoons. Now I know that 1 fluid ounce is 2 tablespoons, but there's another pretty common conversion that 1 cup is 16 tablespoons. Let's do that first. Save ourselves a little step rather than going to fluid ounces and then to cups. Go straight to cups. Then I know that there are 2 cups in 1 pint. And finally, we know pints, quart, pints. Last step, 4 quarts in a gallon. So now we do have pounds per gallon. On top, we're going to combine 0.3 times 1 pound times 16 times 2 times 2 times 4. $76.8 pounds. On bottom, we've got 1 times 16 times 1 times 9 times 1 gallon, so that's 6. Divide that out. 76.8 divided by 16, 4.8 pounds per gallon. Add it in. We might have, let's say we're looking at a motor, fuel consumption. We might have a motor that is burning 3 tablespoons per second. We want to turn that into gallons per hour. So again, we're going to write that as 3 tablespoons second. I have to turn the tablespoons into gallons again. So, there's 16 tablespoons in 1 cup. We'll go to that one first. So there are 2 cups. Pint. For the pints. Pints in a quart. Pints, and we finally have to get to gallons from quarts. We know there's 4 quarts, 1 gallon. So the quarts are gone. So right now we are in gallons per second. We want it gallons per hour. So we have to change the seconds to hours. The seconds are on bottom, so we're going to put seconds on top. 1 hour. Again, we combine the 60 and the 60 to make it 3,600 seconds. Seconds are gone. We are now in gallons per hour. So on top we have 3 times 1 times 1 times 1 times 1 times 3,600. 1,800 gallons. On bottom we got 1 times 16 times 2 times 2 times 4 times 1 hour. What was that, 256 hours? It's 42.19, we'll call it, gallons per hour of fuel consumption. That's a pretty hefty motor there. Many of your larger motors might burn, industrial motors might burn 7 or 8 gallons per hour. 42 gallons per hour is a very, very large industrial motor. So let's look at metric rates. First type I want to look at is a mixture of metric and standard, because remember, time is metric no matter what. So if we have something like, we might be using 12 kilograms per hour. Wondering what's that going to be in grams per second. Kilograms over 1 hour. We need to change kilograms to grams, and we need to change hours to seconds. It really doesn't matter which one we do first, but because it's a mixture of standard and metric units, we're going to have to do 2 separate processes for it. We can't do it all out in one big chain like we did up here. Well, we could, but it makes things a little different for us. I'm going to do let's do my kilograms first. Changing kilograms to grams. On my chart, to get from kilograms to grams, I have to move 3 spots to the right. So I'm moving my decimal point here 3 spots to the right, filling in zeros. So it's 12,000 grams per 1 hour. Now I still have to get rid of the hours. So now I go back to using my conversion factors again, my dimensional analysis. 1 hour is, I'm going to seconds, so it's 3,600 seconds. Hours cancel out. 12,000 grams over 3,600 seconds. I have to divide that out. 33, and extra 3.333 is what that should be. grams per second. So there we had to do both processes. We had to do the decimal movement, and we had to do that dimensional analysis, that conversion factor to cancel out the units. Because we had both the metric units, kilograms, and we had time, which is always standard. If both units are metric, it makes life a lot easier on us. We might have something like, let's say we know that it weighs 24.6 kilograms per meter squared, and we want to convert that into grams per centimeter squared. Oh, set this up as 24.6 kilograms over 1 meter squared. Now, both of those units can be changed because they're both metric. Both can be changed by just moving the decimal point. Kilograms are going to go to grams. So from kilograms to grams, if we look at our chart, that's still 3 spots to the right. I'm just going to move my decimal point, 1, 2, 3, filling in those zeros. 24,600 grams. Meters squared has to go to centimeters squared. Now from meters to centimeters on the chart is 2 spots to the right. But because it's squared, every spot on the chart is 2 decimal places. So 2 spots on the chart becomes 4 decimal places. There's no decimal point written there. We put it at the end of the number, so it's after the 1. And we move it 4 spots to the right, filling in those zeros, 4 zeros. This is 10,000 centimeters squared. 24,600 grams divided by 10,000, or 6 squared. So notice the digits actually stay the same, it's just moving the decimal point eventually, just like any other metric. So we might have one that looks like this. Go 540 kilograms per meter cubed, and I want to know what is that in kilograms per millimeter cube. This is still 540 kilograms over 1 meter cube. Have to get rid of the kilograms. Oops. Changing kilograms into milligrams. Well, to get from kilograms to milligrams, let's set up my chart over here. We pretty much go on the full length of the chart here. Kilograms to milligrams, we're going 6 places to the right. So we have to take our decimal point and move it 6 spots to the right, filling in zeros. This is 540 million milligrams. Now for the meter cubed, going to millimeters cubed, on the chart from meters to millimeters, also 3 spots to the right, but this is cubed. So since it's cubed, every spot on the chart is 3 decimal places. So 3 spots on the chart turns into 9 decimal places. So starting at there's no decimal point written, so it's after the 1. We have to go 9 spots to the right. That is 1 billion. There's cubed. We have to divide that out. 540 million divided by 1 billion is 0.54 kilograms per millimeter. I'm going to have you guys practice one of the metric conversions. We are going to go kilograms per millimeter square. That's grams per centimeter square. Give you a minute to do that conversion, then we'll go over it.
Gra 24, 28 grams over 1 millimeter squared. Oh, by the way, how are you doing today?
Good. Let's take a look at this one. So we're going to change our milligrams from the grams. Now this one's going the other direction. From milligrams to grams is 3 spots to the left. So we're going to move our decimal point 3 spots to the left. So it starts here, we go 1, 2, and we have to add a 0 to go 3. 0.028. We have to change millimeters squared to centimeters squared. Millimeters to centimeters. 1 spot to the left on the chart. But since it's squared, we got to go 2 spots or 2 decimal places for every spot on the chart. So starting there, we go 1, and if we add 0 to go 2. That's 0.01 centimeters squared. And we divide that out, it gives us 2.8 grams per centimeter squared. Okay, so with that, that's really all I had wanted to make sure we went over today. There is a quiz. I'll get it posted here as soon as we're done recording. No new homework. Like I said, I will get that quiz posted for you so you can work on that. Technically, it's not due till tomorrow. I'll get it out there so you have something to work on. Anybody have any questions? Okay, we'll end the recording there.